Hey y'all, and welcome to a special edition Hanging with Hobo Live. And this live stream spawned from two requests today for help, requesting help from two different viewers. And just with everything I've got going on, I was going to try to do a one-on-one with each of them, but I just don't have time. So I'm going to go over these very specific requests for how to do something in this live stream. I will try and pay some attention to the comments and the questions, but I figured, hey, you know what? They've got a request, and one of them is actually a pretty common problem when it comes to using your diode laser and trying to engrave something in, say, that has a lip on it, and it's your focus has got to be lower than the edge of the bowl, so or a tray or what have you. Or, for example, let me grab my tray here. Say I wanted to engrave down in the bottom of that tray. Well, I've got to get that's over 10 millimeters deep, so I've got to get the laser inside there and it not be bouncing around and hitting this, or when finished dragging this off. So I'm going to be addressing how you do that using Lightburn and what settings to use. And this is about one of the only times you would ever use, not the only one of the only times, but it's one of the times that I use the settings for current position. I almost always work absolute coordinates, but a situation like this will require you to use current position. But I've also had a request about how to recreate the image of a slotted rotor. And I'm not going to bother mentioning the people who reached out for help. If they chime in here and they identify it and claim it, then hey, we'll speak about it. But I'm not going to call anybody out. But there was a request about needing to recreate the image of a slotted rotor design. And if you don't know what a slotted rotor is, or slotted brake disc rotor, you'll see here in just a few minutes. But before I go into that one, let's talk about the techniques required to engrave in a recessed area using Lightburn and not have any interference problems. Now, I tell you guys all the time, there's always more than one way to do things. I'm going to tell you how I do this. There might be a better way, there might be a simpler way, but this is how I do it and how it works for me. So I do not use absolute coordinates when I'm needing to do this. I will go into Lightburn and switch over to current position. And you're like, what? Huh? Well, if we go over to, I got Lightburn open. Yep, there we go. In my laser control menu, here you have start from. This is currently set on absolute coordinates, but you can do absolute coordinates, user origin, or current position. For this particular type of job, I will use current position. Okay. And if you notice, when I switched it, my origin here jumped, or my little green dot jumped over here. In fact, I need to turn the laser on so you can see this. So I might turn the fans on for a second. All right. And reestablish communications. All right. Now, so we are at home. If I take and grab my, now here's why I use current position. If I've got this, I lay it on my laser bed. I've got to have the laser high enough to get it over the lip and then focus it down in the pocket where I need it. So this needs to be positioned squared up. You can use a framing square or a jig, whatever you've got, to make sure you've got it squared up and in the right position. If you wanted to put it in the home position and in the corner of your honeycomb, you could do that if you've got room for it. But the key is, once you put this down here, this doesn't want to move. You can't move this. In fact, you might if you don't have a jig or you can't put it in the corner. If it's not since this is rectangular, I could put this in the home position. But if the request that came in was for engraving the bottom of a candy dish. So I'm guessing that candy dish is probably circular or oval, or maybe some funky shape, and you can't use a square or something. So you would need to potentially put some tape on it, two-way tape, or folded up tape, and then tape that to your honeycomb so it's in a fixed position, it doesn't move. Then raise your laser as high, or not as high as you need to, and then using your move control buttons in Lightburn, you can actually go over here and just drop a pin, select your pin, and say if it's right here, kind of in the middle, drop a pin there in the middle, and you can see the laser moved over there. And now that's where the laser's headed. The laser's there. And if I have my origin for my artwork, and you'll see all that in a minute once I put all the origin on, is in the center, that's in the center. It's all going to make sense in a second. But I've got that there. I've got it raised up. I'm able to put this in a fixed position. I've got it taped down or secured down or in a jig. It's not going to move. I'll use my focal stick to go in and get it at the right height. Now this is interesting. The pocket is really, really small on this. And because of my clearance that I've got with the laser module with the mounting brackets, I don't have a whole lot of room for that laser to move before it starts having interference issues. So that's the other thing you need to check is how much can that laser move without banging into the sides or your lip. So hopefully you're doing a pretty large piece, or else you're only going to be engraving a very, very small area. But you get that lowered down and focused where it needs to be. You lock it in place. Now you've got it focused, but where does it need to be? Well, before you've done all that, what you need to do with your actual piece is find the center of the area that needs to be engraved. So you can either eyeball it, especially if it's an irregular shape. That might be your best bet, is to look at it and eyeball it and just kind of put a little mark right and where you want the center of that engraving to be. If it's rectangular or a fixed shape and you can find the exact center, do that. But you mark that center position that you want your engraving to be. Now you got a physical mark there. You put it right there. You focus your laser. Lock that into place. And then once you've got that done, it's fixed, it's focused, but you don't have it positioned yet. So you have to have a representation of the area you're going to engrave in Lightburn. So this one being a simple rectangular shape, you take your measurements, get your exact dimensions, because your recreation in Lightburn needs to be exactly what you're working with. So in this case, I'm only just going to do a quick facsimile of what it would be. And because this is not about the design or the layout or anything. It's about how do you physically accomplish this without it banging into your piece? How do you avoid that lip? Come on, switch. So there's kind of the shape of my piece. And if I'm going to grab some art and I want to put in Cupid in here, that's what I want to engrave in the center of that bowl. All right. I said I want to use current position, but you need to change your job origin to. I like to keep everything centered, because if you look right now, I showed you a second ago, my little green dot. Now that I've added some artwork, this is your origin, and it's over here at the left center. So come down here to job origin and put it in the middle. Now that's in the middle. and we pop that in, get it, there we go. That snapped in the center of that. That's perfectly lined up and that's perfectly centered. Now, how do you get your laser? Well, you can do this a couple of different ways because there's always more than one way. If you have physically secured your engraved piece to the bed and you're not able to move that around, well, now you're going to need to move the laser around to the center of that piece. If you haven't secured this to the bed and you can move this around, then you can move this around to a point that we're getting ready to select using our laser. Remember, you've marked the physical piece with the center of your engraved area. So if I'm going to put this in wireframe mode. So if I take this and I tell my laser to move to the center of this piece, then that's going to be, well, that's the job origin. Then I can come over here to my drop pin and drop it right there on that origin. Now, that is going to make the laser move to the center of that artwork. All right, that's done. If my piece is not, and you can use your fire button in your move here, and you want to have this set at very low power. You can tell it to fire the laser at 1%. And when you fire it, if you have your, depending on your laser, always have your safety glasses on if you don't have your lid closed. But if you got your lid closed, and actually on this, if you need, you're not going to be moving. If you're not moving the physical piece, you can close your lid and use your move control buttons to move around. But if you watch this piece back here, and I've got a physical dot made in the bottom of that tray, and I've told the laser to fire, I can see if the laser lines up with that dot. If it doesn't, then I'm just going to go over to my move buttons here and move it a distance of 1 millimeter and just start physically using those arrows to start moving the module around. You can see it barely moving back there until I get it exactly in the center where that dot's at, or where I want the image to be. Now I've got the laser below the lip. I've got it focused and it's centered right on the graphic. Now you need to set your finish position. Your what? Your finish position. If you've got this artwork sized so that it fits within your constrained area of that lip, you're not having any problems with it running into the edges of the lip. Everything's sized right, works right. Well, once it does all the engraving, and if it's something that's potentially fragile or one of a kind, you don't want that laser bumping into it and you're using the metal on the laser to nick something or scratch something or mess something up. You want the laser to come back and park in a position that it's not going to hit anything. And ideally, that's in the very center of the piece. So to do that, if that's exactly centered up, everything's where it needs to be, then you would come back in over here to light burn. And on your move functions right here, you've got 3 buttons: set origin, clear origin, set finish position. Well, if you just click set finish position right there, that's going to be the new finished position, so that now when you hit start, it's going to go out and engrave this artwork and not interfere with your lip of your piece. And when it's done, it's going to come back and stop right there in the center. And then you can just take it, unlock it, take it out of focus, raise your laser up, and pull your finished piece out, and it's engraved. Now, there's lots of ways you can do this. I went through that really kind of quick, but that's one of the few times that I'll use current position instead of absolute coordinates. And like I said, I wasn't going to mention any names about who asked for that request. In fact, I don't even know if that person's a patron. The next request was needing help on recreating the image or the style of a slotted disc brake rotor. And people probably, I don't know, maybe half of you know what a slotted disc brake rotor is. The other half is like a who? Well, let me pull up one and show you what a slotted disc brake rotor is. Slotted disc brake rotor, slotted disc rotor. There we go. Images. Okay. Now, swap. So these are slotted disc brake rotors. And then you have slotted disc brake rotors and slotted and cross drilled brake rotors. Specifically, this person's needing to be able to recreate a potentially a slotted and cross drilled, maybe just the cross drilled. I don't know. But these are your disc brake rotors that you'll see on just about any car. But these are a little higher performance. They've got the cross drilled circles in there and then the slots in there too. And this is to help with the efficiency on your braking and give you cooler brakes and a quicker braking response. But he's needing to recreate this type of image. And I'm going to guess that they're probably just wanting to do it head on with kind of like this right here, not worrying about having it at an angle. So they were concerned about how they're going to get all of these holes in here set up and positioned right and make it look as accurate as possible. Let's see here. Before I jump into that, let's see here. What's seen some exclamation points? What's that? Oh, Chris says, I was on Facebook helping someone about origins when I got the notification. So I told them to join or watch replay. Okay. Back to the cross drilled rotor. When you're going to recreate something like this that exists in the real world, and somebody says, "Hey, I need to have an image like this." Well, if they're requesting that precise thing, then they've also got a pretty good idea of what it should look like. So you want to try and recreate this as accurately as possible, keeping all of your proportions about the same. I don't know what just happened. Something funky happened in my live stream. Everybody still here? Y'all say hey. Somebody give me a howdy. Okay. Hey. All right. I hate it when they do stuff just out of the clear blue and don't tell you. All right. I don't know what that was. I just got rid of it. A big thing popped up on my screen telling me it's doing something. All right. So if they have an idea what the image looks like, then you need to recreate it as proportionally correctly as possible, or else they're going to go, yeah, it looks okay, but that's not quite what they're supposed to look like. So on a brake disc, it's really simple. If you in fact, you don't even have to have the exact dimensions of the exact brake rotor that they're looking for. You just want to make sure that it's everything about the one you're creating is proportional. And by that, I mean, if you recreated a brake disc that was maybe supposed to be the size of a brake disc that would go on a big 1-ton pickup truck, and then you put only 4 holes in it for the wheel studs and the lug nuts, and it was a really small bolt pattern is what they call it, and there's something else going on again. I'm going to ignore it. Then it's not going to look right. So what I would suggest is doing a little bit of research on what it is you're going to create. So what I'm going to do is I'm going to stay in Google here, and I'm going to go over and I'm going to get a basic couple of measurements. And if you design it from real world dimensions, then you can stretch it and skew it, or you don't want to skew it, but you can shrink it and enlarge it, and everything will stay proportional. So I know, being that I'm a former automotive tech, that the brake rotor on a Honda Civic has 4 lugs and the bolt circle is 100 millimeters. I know that on most of your 5-lug Honda Accords, there are 5 lugs on 114.3 millimeters in a bolt circle. but I don't know what the overall diameter of the average brake disc is. So if I put the exact bolt circle in there, but I don't get the brake disc itself at its right proportion size, then it's going to look funky. So the first thing I'm going to ask for a brake rotor is I'm going to come in here and ask, what is the dimension, or let's see, what is the, not the circumference, but the radius. Yeah. Of a Honda Civic brake rotor. Now, I know you don't need to do a brake rotor. You don't, but the person who asked me for help, they do. But if you're not doing a brake rotor, if you're doing something else, these are some kind of key things to think about when you're designing real world things. You need to kind of base it off of their geometry. So according to Google, the Honda Civic is about 10 1/4 inches. For standard models, and some can be much larger, like 350 for the Type R models. And since we're going to do the high performance stuff, we're going to do this one like the Type R, and we'll say it's 350 mil. All right. So that's the entire diameter, not the radius, but so 350 mil. So I'm going to go back over to Lightburn and clear everything out of here. And I need to draw a circle, perfect circle. And I want to do a Control Shift and draw out from, and actually let's put all this back. I got current position. Yep, current position, that works. So Alt Shift and draw out a perfect circle. Tell it to be 350 mil. All right, now that is the diameter of my brake rotor, but the center part is what they refer to as the hat of the brake rotor. And I got to deselect that so I can create a new one. There we go. Come in here to the center. The center portion, or the hat, I need to know what that is if I want to keep those accurate. So let's go back over here and what is the diameter of the hat on a Honda? Come on, fingers. Honda Civic Type R. Around 69 millimeters. So I can tell that to be 69 mil. Now that's the center bore. That's not the hat. Let's see. That's the center hub. And actually we can try this. Show me a technical drawing for a Honda Civic Type R. Let's see. Brake disc. Images. And there we go. And go away. It's not giving me what well, there it is over here. I'm sorry, right there. So that's 173 mil. And this part that sticks up in the center is what I was referring to as the hat. That's 173 mil. And they're saying here the center hub was 70 mil. But I'm going to just say 173 and leave the other be. So back over to Lightburn. I'll duplicate that, Control D, duplicate it, and tell it to be 173 mil. All right, so now I'm starting to get a brake disc in the right proportions. And I know that the Type R might be a 5 lug. And they do have it pictured here as a potential 5 lug wheel. You've got 10 holes in here, plus these 2 smaller holes, and we'll talk about those here in a second. But they are 12 millimeter in diameter because they're a 12 millimeter 1.50 thread. So if I take that and I tell it to be a 12 millimeter diameter circle, and I'm going to, if I want to make sure it's in the center of that, I can simply just draw a straight line from right there to the top of that one, and then take that circle, select that line, and tell it to go to the center. There it is. Now with that centered up, I can get rid of that, select this, select that inner circle, go to your circular array, and do 10 copies for this one. And say, okay, we don't need to group them, but we'll say, okay, done. So there's, it's a 5 lug wheel. So there's, but you seen the image there, they had 10 holes in it. That's the right diameter for the wheel studs. And now there were 2 holes that were kind of opposite each other. They were a little smaller. And for those who don't know, those are just holes that you can take. They're usually 13 millimeter screws that you can thread into there, and it'll press the brake rotor off if it's stuck on there. If you're in a coastal area, a lot of salt, a lot of rust, or in the snow, and you got a lot of stuff going on, those things get hung up. So use those to press them off. And we're trying to make this look as much like a brake rotor as possible. So, and his specific concerns and request was how to recreate all of those cross-drilled holes all the way around it. You already just seen a little bit of a hint there. We're going to use the circular array tool, but it's not just the circular array tool where you want to use that and also copy path along line or copy a long line and help either give them an arc and keep everything spaced evenly, but we'll get in there. So let's put these 2 random circles in here, and they are really not that random. They're 13 millimeter typically. So we'll give it a 13 mil, not 13 mil. I'm sorry, 10 mil. Don't know what I was thinking. 10 millimeter. And did I give those 12? Yeah, I got those 12, but these are not. Oh, brain fart. The hex head on the bolt that you screw in is a 10 millimeter hex head. The threads are not. The threads are probably about an 8 millimeter bolt. Oh, wrong button there and back to here. So let's make that 8 millimeter. There we go. That's better. And those are in between 2 of these and then directly opposite one another. And if you wanted to make sure you're getting them exactly right, well, you could do the same thing. You could take that, and tell it you want to do a circular array, and we only need 2 copies. And doing 2 copies, we'll put it exactly opposite one another. And this time we are going to group it and say, okay, because I want to rotate it just a little bit. So I'm going to use my rotate function, and I'm going to rotate it 1 degree. That looks better. And say, okay. So now those are kind of in position. I got my right number of bolt holes. Starting to look like a brake disc. Now, how do I get my cross drills in there? Now, if we go back and look at that image, and you'll see you got this one's simply just a cross drilled. It's got all these holes all the way around here. They've also got a little bit of an arc, and this is 4. This is 4, but this one is 1, 2, 3, 4, 5. So, and it looks like there might be some other stuff going on here too. But if you really want to just kind of keep it uniform, because the Brembo is like ultra high end braking. If we go back, you'll see a lot of these are just simply the same 3 holes all the way around, or 4 holes. But then you've got, let's go back, because you've got some that are cross drilled and slotted. Let's see here. Here, there we go, like this. So there's 4 holes that have got a little bit of an arc on them, and then there's a slot in between them. So let's recreate this one, because the cross drill slotted is one of the more popular designs, and that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 of each. 6 sets of 4 cross drilled and 6 slots. So 6 and 6 is 12. All right. Go back over here. And first thing I'm going to do is don't want to do that. Let's draw a straight line. And we're going to draw it at a 45-degree angle. And I'll draw it from here. I'm holding shift, start drawing a straight line, and holding shift makes it be a straight up at 0, that straight out at 90, that straight up 45-degree angle. Holding shift forces it at a 90 or 45-degree angle. So there's that. Now I'm going to select that, and I'm going to put it at top dead, or put it in the vertical center. Now, if I want to make sure it's centered up inside there, and if I wanted to get real technical, I go back and I'd get the exact length of those slots, but you can see they don't quite go all the way to the edge, and there's a little bit of a lip in there that you would maybe want to recreate in your, and you could do that by just simply duplicating that and increase it just a little bit like that. There you go. And now draw another straight line from here to here, and then select that slot and tell it to go to the center of that. Now that's positioned just right. Get rid of that one. And now let's, instead of a slot, instead of a line, let's make that look like that slotted groove. Mirror line and current. It's currently against rotation. Depends on which rotation you're going in, Chris. And this is, it's funny. The cheaper cross drilled and slotted rotors are not directional. If you go into here in the US, Napa or O'Reilly's, and you just walk in and say, I need to get a couple of cross drilled slotted rotors for Honda Civic, they're going to give you 2 that are identical. And if you put one on the right side, it's going to be running one way. You put one on the left side, it's running in the other direction. They're not all directional. And there's even a debate about which way is the correct way for direction of rotation. Some folks like this would say that slot should be rotating clockwise. And then other folks say that, well, that's not wind swept or wing swept. That actually would be rotating counterclockwise. So there's a whole debate about which one's right. And I'm not going to get into that. I'm not going to go that far into it. This is more about the making it look right and getting the position correct for all those things. So, and those slots, they were straight lines. They didn't have any curve to them. They were just straight lines. But you see the cross drills have got a little bit of a curve, and we'll address that in a minute. So if we go back over here and do this straight line, it's just a line right now, but I want to give it a groove. So I'm going to do an offset, and that's way too big. We'll just come down here and give it maybe an offset like that, and delete the original and say, okay. Now hold shift and select any of those circles, do another circular array. And this time we need 6 of those. And there those are. And say, and I'm going to group those and say, okay. Now, actually, let's see. Yeah, that'll work. So that gives me the proper position for that. But now I need to get 6 of the cross drill holes evenly spaced in between those. And there's a couple of different ways I can approach this. I'm trying to think of the laziest way to do it to get that spacing just right. If I were to take that, and actually now let's ungroup that so I can grab one of those again. So grab one of those. This time I'm going to do another circular array. Nope, I didn't get that circle. Hold shift, grab the circle, do another circular array, but this time do 12 copies and make sure that those are grouped and say okay. And actually I don't want that one in that group. So I'm going to hit ungroup, hold shift, deselect that one and group those back together. There we go. So now just those 6 are in that group, and those 6 are where I need those slotted holes to be. So I'm going to take and draw a line from that center intersection point to that one. And actually, now that I've done that, I don't need that group anymore. I can get rid of that group. This needs to have a little bit of a curve to it, and we're going to put it on a tool path. Go to where now we go, and then I'm going to hit M for middle, and I'm going to just stretch that node up a little bit, give it an S, make it smooth. There we go. And bend these handles here so that they all go up and out. Done. All right. Now I've got a curve that's in between those. I'm going to come in here and grab me a circle and put me in here a 8mm hole. Let's put it on a red so we can sit and tell it to be 8mm. And it's right there on that line. Hold shift, select that line, go to the arrange menu and tell it to copy along path. I want 4 copies along path. Say okay. Now I'm going to select the tool path, those 4, group all of that together, hold shift, select that circle, go back to my circular array and go back to just 6 copies and say okay. Group the results, that's fine. And I can turn that tool path off so I don't see it. Paths, cuts layers. There we go. And turn that off there. So there I have that. That one's actually a little bit close to the edge, and I didn't pay any attention to that. Let's go back. Control Z, Control Z, Control Z, Control Z, Control Z, Control Z, Control Z. And let's take it all the way down to that line. Go all the way back to where it's straight. There we go. And because that 8mm was centered on the edge or in the middle of the end of that line, it got it out close to the edge. So that needs to be a little bit smaller in length. And I'm just going to, well, actually, you know what? I'm going to come over here. Look at my angle. The angle is 15 degrees. So if I were to come in here and tell that to rotate 15 degrees, that's going to make it a straight line. And now I can just tell that, or just hold control and bring that down, shrink it on down. There we go. And then rotate that back -15 degrees. That keeps everything in the exact same position. Let's go back to that circle, go to the end of that line, hold shift and control. 8mm. Shift and copy along path in the arrange menu. 4 copies. Oh, I didn't curve the line. Getting ahead of myself. Hit the letter S to make that smooth and just kind of pull that out, give it some curve. Grab these handles and bring them above the line. So, because right now it kind of dips down and then goes up. So get that handle above that line and that'll give you a continuous curve all the way around. And now grab that circle, that line, arrange menu, copy along path, 4 copies, say okay. That's good, away from the center. And hold, select all of that, group it, circular array tool, 6 copies, okay. Turn off my toolpath. That looks pretty darn good. Now, obviously, you don't want to cut or engrave a 350 mil, but now when you shrink that down to whatever size you need it to be, all of your proportions are going to be correct. And if you went with a really, really, really cheap brake disc that still had some of these features, it would only be a potentially a 5 lug wheel. It wouldn't have all 10 holes in here. So if you got rid of every other one, now you can see, okay, that looks even more like, you know, some of the cheaper ones. But this was just an attempt to show, you know, they were worried to death about how to recreate all those holes, get them spaced out exactly right, get everything looking as close to as realistic as possible. And to do that, you need to start with some realistic geometry to begin with. You can use a little bit of artistic liberties once you at least start from a decent foundation. But using the copy along path and making sure you've got everything spaced, you know, evenly between them, you know, top to bottom between the outer perimeter and your hat, all those things. Those are tips to really making it look as close to as a realistic piece of, you know, a part you're going to go buy that off the shelf. That's real close to a technical drawing right there without doing all of the very, very specific measurements. But that's good enough for any kind of engraving thing. So now that I've got those were the 2 main things that I really wanted to show, because those were requests. How do I do this? Well, when you need to do the engraving on anything that has a lip, use current position, get it under your laser, lower your laser into place, make sure you're not going to have a clearance issue with the outer perimeter of your laser itself when it goes to move around. Check that by, you know, framing. And another trick you can do, if you have a circular piece, if it's a dish, or even if it's not circular, if it's something like this, and you're not sure how big your image needs to be, well, take you a piece of cardstock and cut out the perimeter of that shape you want to engrave, and lay it in there and say, okay, does that look good, or is that too big? You know, is it too small? What I need to do with it. But mark your position, physically mark it in the bottom of your tray, lay that in there, lower your laser, get it focused, then use your fire button to fire the laser and move the laser around to where it's centered exactly where you want the image to be centered, and then place your image in that location. And that might be something I ought to show you just for giggles. Let's say, well, we can just use this rotor. Say this was a dish and I needed this was a lip that was sticking out. These 2 actually were sticking up really high and proud, and I needed to get an image inside here. Well, I've got that dish is on the laser, everything's focused and everything's where it needs to be, and I have the laser put right there. Well, if I have, let's see, where I don't have the laser turned on. Let me turn the laser on. And I just updated Lightburn again. I've got 2.0.05 and it still don't work with my laser. My laser was just moving. I don't have a connection. I am on the right COM port. In order for me to reestablish connection, I have to reset my device by right-clicking, and it'll reset. And once it does, it'll move to the home position. Now it's at the home position, and I've got my crosshairs right there to tell me where the laser's at. But if I'm using current position here, and I want, let's take and put my laser in the center of this. Done. So now my laser is going to move to the center of that circle, and you see my crosshairs showed up there. So that tells me that's where my laser's at. Wherever those little crosshairs is where your laser's at on your workbed. So now if I wanted to put this cupid in the center of that piece, put that. Well, actually, you know what? I'm not even going to use that circle, because what if you didn't have that circle or that path? If you had a very odd shape and you've made the position marked physically on your physical piece, put it under your laser, use the move controls to get the laser where it's right over that dot, and you have nothing on your toolpath or nothing on the workbed at all. You don't have a shape. And you know that what the size of your image needs to be, because you've kind of cut a few pieces to know, all right, well, I know this 1 inch piece works or this 2 inch piece works. Then you don't even have to worry about having any kind of outer perimeter toolpath or any of that. You don't need any of that. If you already have tested the right size for that particular piece, then all you have to do is, in fact, we won't even do that. We're going to come over here and drop the laser right there. So I've got nothing on my bed. I know where the center of my laser's at. My laser is right there, and that laser is pointing, and when I did my test fire, it's pointing right at the center piece where I want that engraving to take place. Well, all I got to do is, if this is the artwork that I want to be at that position, come up here and use these, which is move to laser position with the red dot in it. And look what happens. It moved it to where that artwork is in the very center of the laser's current position. So by using that move feature, and if you don't see that, then you would have to you may not see it if you don't have your windows arranged long turned on. If you have window arrange long turned off, but you have the arrange turned on, you don't see that crosshairs with the red circle. If you clicked on there, you can get it. There it is right there, move to laser. But I use Windows arrange long. There it is. Turn off arrange. And I hate that it closes every time you do that. There we go. So I've got it right there on my tool bed. So you select that and then tell it to go to the laser center position. That will move your artwork exactly under where you have the laser pointed at now. And now you can set up your power set and speed settings, engrave it. Make sure that you have set your finished position to that exact same spot, and the laser will come right back to there. Never hit your lips, never hit your bowls, your trays, whatever you're working with. Okay. Let's turn this off. And Bob says, I didn't get any notification. Well, Bob, I didn't give any notification. These were 2 requests that I had come in today, this afternoon, from 2 different viewers needing some help with 2 very specific things. And I've got a lot going on still. And I need to do some errands tonight. I need to run some people around. So I said, instead of trying to wait for them to have time to come and meet me and go one-on-one, I said, you know what? I'll just do a quick live stream, show this, and then email them and tell them, hey, I've got a live that I just did tonight that addresses your specific request. Everybody who wants to watch it has watched it, but now they can see this and they can back it up and watch it as many times as they want, and hopefully it will address their specific needs. But no, there was no advanced notification because I sat down here and just went go live. But anyway, this was a special request. I've got today is Wednesday. I'm going to look at an RV on Friday. This one is actually in upstate Georgia, and it'll take me all day Friday to if I buy this one. It'll be Friday evening before I'm back with it. I won't even bother trying to get everything set up on Friday. I will start moving stuff out of my current RV into the new one Saturday, and we'll go live Saturday night at 8 p.m. Eastern time. And that way I'll get as much done as I can Saturday before needing to go live. Don't know what we're going to do Saturday yet. Nobody's asked me for anything in particular that made me go, hey, that's a good live stream. We'll do that. Yeah, not bad result. 44 watching with no notifications at all going out. And like I said, this actually was for 2 people, you know, and if those 2 people get to see it and they are able to accomplish what they want to, then I've accomplished what I needed to with helping those 2 folks. And if any of you 44 that are here have had a chance to watch this and you learn anything from it or thought, oh, you know, I never thought about doing it that way. That's just a different way of doing it. Because I promise you, there's another way to do these things. There's always another way. So let's get rid of that. And I didn't get all of the stupid Cupid when I did it. Well, thank you, Carl. I'm glad you thought it was interesting and informative. But I think that is a pretty darn good representation of a cross-drilled slotted rotor. But now I'm curious, Chris, since you were mentioning about mirroring and changing the direction of the slot a minute ago, what is your opinion? Is that a rotor that would go on the right side of the car or the left side of the car? Would you have the direction of rotation going as it goes forward? You know, is this the left side or is it the right side? And I'll tell you the 2 different opinions here. That's a large debate that, and some of it's based strictly on appearance and not a whole lot of, okay, so you're saying it's the left side. And being a right-hand drive or left-hand drive wouldn't matter. It's the left side of the car. You think that's the left side, and Jer says left side. Now, see, Kevin says driver's side. See, I knew there would be a difference. I knew that people would think differently. And here's where a lot of the perception of what it is based strictly on the appearance. And Ed says left side. If I was going to say, well, these are wind swept slots, then yes, they're going to be, as the car's moving forward, then it's swept backwards. So that would be a left side on, you know, a left side rotor, right-hand drive or left-hand drive wouldn't matter. That'd be on the left side of the car. But the other school of thought is that it's not wind swept, but it's biting. It's like a claw as it rotates. So it's biting into the road or the asphalt or the snow or the whatever. So then that would be the right side. So as it's rotating, it's grabbing and pulling forward. And based on what I have seen when changing tires. Well, and the direction on this is a little tread direction. You would have tire tread. You're going to have the narrow point going forward, and then it's swept back. And tread design's a little different than wheels and brake rotors, because on the I forget what year Corvette it was, but Corvettes for many years they had different directional wheels. And they really made it a nightmare on a couple of years because they didn't have directional wheels. They didn't have left and right side. There were a few years that the Corvette had a left front wheel and a right rear wheel. You know, the wheel was only in one position for that vehicle, period, because the front and rear were different widths and they were rotating in a different direction as far as, you know, that windswept or aggressive. And on the Corvette, they did not go with, I'm 90% sure they didn't go with the windswept concept. They went with the idea that those vanes are actually grabbing forward and biting into the air and aggressing itself forward. Me personally, the spinners you can put on cars and anything that had vanes that were directional, I always liked it when it looked more like it was swept with the wind. Chris says I had a spill on my bike due to directional tire changing different. Yeah, that could be very bad. Yeah, a directional tire going the wrong way will catch the water and cause you to hydroplane, and you know what happens. Let's see here. Go over here, and I'm gonna look something real quick. Let's see. Yeah, here we go. Is this going to be, so yeah. Okay. So here is an example. Let me get this to load. Can I get a bigger picture than that? If I zoom in, we can. All right. So these are the wheel spinners that go in the center of some of your aftermarket wheels. And you've got these two that are identical and these two that are identical. And these are twisted. I would say those are twisted in a clockwise, and these are twisted in a counterclockwise. And just for anybody that's still here, is this one for the left side of the car or for the right side of the car? Is this a left or a right? What's everybody say? This has nothing to do with light burn. This is just a strange, topic that came up, because there will be a 50-50 split. Some will say right, some will say left. And it even tells you here, you got 3-bar swept wings, left and right. And Bob says that this is a right side, and I would agree that's a right side because it is a swept. It's wind swept, so it's swept back. Hold on, guys. I'll be with you in a second. What? I'm actually live. What's up? Yeah, you are asking. That wasn't ask. Yeah. I'm wrapping it up here in just a few minutes. Huh? All right. So anyway, switch back. All right. So that's that. Hopefully, and I will send, before I leave here, I'm going to send an email to the 2 folks that had a request about this information, make sure they see the opportunity to see this, and hopefully it addresses their issues. And I appreciate the handful of you jumping in here and hanging out for a little bit tonight. Like I said, this was just the easiest way to help those folks that needed this information. I got to go run errands because I'm being paged. I'm gonna start. I think I used to, when it was safe before the world went crazy, I used to do a little bit of Uber driving. I think I'm going to start doing Uber driving again. All right. So, all right, boys and girls, I'm out of here. I will see you Saturday night, 8 p.m. Eastern time. And I know a lot of you that are here right now are across the pond. I don't know that I'm going to be able to go back to doing 2 streams initially until I get my world less on fire on Saturdays, and I'll just have to play it by ear. I'm going a little bit earlier at 8, so it's not as late if you guys want to catch it, but I may get back to getting that afternoon stream going too, just as soon as my world calms down, just a little bit. All right, I'm out. I'll see you this weekend.